Hello my dear students, welcome back to our JEE Prep channel. Hope all of you are doing well. In the previous videos, we have seen the concept of displacement, velocity and acceleration. And all these quantities depends on time. And then we have studied the three kinematical equations also. What are those three kinematical equations? First kinematical equation is V is equal to U plus AT. Second kinematical equation is ut plus half at square, and the third kinematical equation is v square is equal to u square plus 2as. Now, today we will study the graphs, variation of displacement with respect to time, variation of velocity with respect to time in different circumstances. So first we will study variation of displacement with respect to time, means displacement versus time graph, and they are also called as the position versus time graph. Now in all these graphs, displacement is plotted along y-axis where time is plotted along x-axis. So first we will study the position time graph for the stationary body, that means body is at rest permanently. Second is the position time graph for the uniform motion, means the body is moving uniformly with constant speed in the same direction. And the third graph will be for uniformly accelerated motion, means body is moving with constant acceleration. Let's start it now. Now consider the first case, the body is at rest. Then what is the position versus time graph? We are plotting time along x-axis while displacement along y-axis. Now as the body is at rest, as the time increases, the body remains at that particular position. For example, take this case. I have kept a body of mass m at 3 meter from this reference point. Therefore, next 4 seconds body is at 3 meter only. So therefore, this becomes the observation table for this situation, and let us plot these points, these values on the graph. At t equal to 0, the body is at 3 meter. At t equal to 1 second, body is again at 3 meter. At t is equal to 2 seconds, body is at 3 meter. 3 seconds and 4 seconds also body is at 3 meter only. So the position of the body does not change because body is at rest. Now let us go for the second graph, that is the position time graph for uniform motion. Now what do you mean by uniform motion? We know the uniform motion means motion of the body moving with constant velocity. Motion of the body which is covering equal distance in equal time. Now here I have plotted time along x-axis while position, that is displacement, along y-axis. Then this is the observation table. Means what? At t equal to 0, the body is at rest. Then at t equal to 0, body is at rest, hence the displacement is 0. After 1 second, body covers 1 meter distance. Then next, after 1 second, body covers 2 meter distance. In 3 seconds, body covers 3 meter distance. And in 4 seconds, body covers 4 meter distance. That means the body covers equal distance in equal time. So now you can plot these points here on the coordinate axis. On x-axis, as I told you that on x-axis time is being plotted and the displacement is plotted along y-axis. Then we get this straight line. Now the slope of this line gives the velocity. This theta is the angle made by this line with the x-axis, means time axis. Now suppose this is the t1 time, that time displacement of the body is x1 and t is equal to 3 seconds is the t2 time, and the displacement at t2 seconds is 3 meter. So then the velocity of the body is x2 minus x1 upon t2 minus t1, which is actually slow because this is the change in y coordinate divided by change in x coordinate. So this comes to be 3 minus 2 upon 3 minus 2, it comes to be 1 meter per second. Hence, the slope of this line will give you the velocity. Also, students, you have to note one point. if this angle theta is large, means slope is large, that means value of tan theta is more, at time velocity is also more. Means, suppose if I plot this graph of displacement versus time, time is plotted along x-axis and displacement is plotted along y-axis. Now, this is the first car which is moving with certain velocity, and this is the angle made by this line with the time axis, and this is the second car which is moving with certain another velocity, and then this is the angle theta made by this line. Now, here the change in displacement with respect to time is more, therefore this car is moving with more velocity. And here change in displacement with respect to time is less, therefore this car is moving with less velocity. Means this car is more faster than first car. And now we can show it in other way also. See this. See, for the first car A, see, for the same time, the change in displacement of the first car is this much, while for the second car, the change in the displacement is more for the second car. Hence, the second car is moving more faster than the first car. So, this is the position time graph for the uniform motion. Now, let's study the position time graph for uniformly accelerated motion. Now, here in this case, the body is moving with constant acceleration. Means the speed of the body is increasing uniformly. Acceleration is constant. Now, this is the nature of the graph. Here again time is plotted along x-axis while displacement is plotted along y-axis. And this is the nature of this graph. This is the curve. Now, how did we get this curve, or how did we get this kind of nature? Let's start with the second kinematic equation. What is the second kinematic equation? S is equal to ut plus half at square. Now, for the sake of understanding, let us consider that the body starts from rest and it is moving with acceleration 2 meters per second square. So, now when we say that the body starts from rest, that means u is equal to 0 and the body is moving with constant acceleration with 2 meters per second square. Now, what do you mean by 2 meters per second square? The speed of the body is increasing by 2 meters per second for every second. What do you mean by A is equal to 3 meters per second square? The speed of the body is increasing by 3 meters per second for every second. So, here we have taken A is equal to 2 meters per second for the sake of understanding. Now, let us substitute these values in this equation and get one formula which gives the variation of displacement with respect to time. So, S is equal to 0 into t plus half into 2t square. So, therefore, this is S is equal to, now this 2 cancels, this is 0, so this is t square. So, hence, S is equal to t square. Now, we come to the variation of displacement with respect to time. This is t square. So, now what we have to do? Now, we have to find out the displacement at different time. Means we want to find out the displacement of the body when t is equal to 0, when t is equal to 1 second, when t is equal to 2 seconds, and so on. So, these are the values here in this table. So, when you put t is equal to 0, displacement is 0. When t is equal to 1, displacement is 1. T equal to 2, then the displacement is 4. Then when I put t is equal to 3, displacement is 9. And when I put t is equal to 4, displacement comes to be 16 meters. Now, if you plot this, then you get this graph. So, Now we have studied the three types of graph for the position and time graphs. First, we have studied the position and time graph for where the body is at rest. Then this is the position and time graph for body moving with constant velocity, and another one is the position versus time when the body is moving with constant acceleration. I hope all of you understood this three graphs of position versus time. And students, to understand the concepts in physics, I strongly recommend all of you to subscribe our channel.